Hello, pre-calc students. Today we're doing inverses and composites. And first we're going to do the quick notes, and then going to go through the problems. So the inverse function switches all points x, y to y, x. So what we're doing here is we're switching the inputs to the outputs and the outputs to the inputs. Geometrically, this is the same as a reflection about the line y equals x. In a one-to-one function, so remember, a one-to-one function is where a function passes the horizontal line test. So this function is one-to-one. However, a parabola is not one-to-one because it fails the horizontal line test. Only one-to-one functions have inverses that are functions. If you have a function that's not one-to-one, like a parabola, you might have to restrict the domain in order to find the inverse. All right, moving on. A composition of two functions is a function inside of a function. So f circle g of x. Put g of x inside of f of x. That would look like f of g of x. And g circle f of x, you put f of x inside g of x. So that would look like this composition, g of f of x. All right. The composition of a function and its inverse is I always equal to x, which is the original input. So anytime you take the composition of f of the inverse of f of x, that's going to be equal to x. So if g of x is the inverse of f of x, then the composition of the two will be equal to the original input. All right, moving on, let's get to the multiple choice practice. All right, what is the inverse of f of x is equal to x minus 2 squared plus 3 if x is less than or equal to 2? So here our first step is to switch the y's and the x's. So this y, because f of x is the y term, becomes x. X is equal to, parentheses, y minus 2 squared plus 3. Subtract 3. X minus 3 is equal to, parentheses, y minus 2 squared. So we subtracted 3 from both sides. All right, and now we have to isolate the y. So we take the square root of both sides. So the square root is going to be equal to the square root of x minus 3 is equal to y minus 2. All right, and then we add 2 to each side. So y is equal to the square root of x minus 3 plus 2. And so this is the inverse of the function. So this is equal to the inverse of f of x. And what it meant to have here is plus minus. So just ignore those dashes, but the answer is B. And so that was just a small typo there. Let f of x equal x over x minus 3 and g of x equal x plus 1 over 2x. What is the domain of f of g of x? That means we plug g of x into f of x. So we have x plus 1 over 2x over x plus 1 over 2x minus 3. Plus 1 over 2x minus 3. So let's look at x plus 1 over 2x minus 3. We need to get a common denominator for a negative 3. So we multiply negative 3 by the denominator that we need to have for negative 3 over itself. So we're not changing the actual value of the term. So we multiply by 2x over 2x. So we're going to ultimately get x plus 1 over 2x, but now negative 3 becomes negative minus 3 times negative 2x is minus 6x over 2x. And simplifying it, x minus 6x is equal to negative 5x plus 1 over 2x. So simplifying this term right here, we get x plus 1 over 2x divided by negative 5x plus 1 over 2x. So we're dividing two fractions here. So we're really getting the equation x plus 1 over 2x divided by negative 5x plus 1 over 2x. And when you divide fractions, you change the second one. So this will become x plus 1 over 2x times 2x over negative 5x plus 1, and the 2x's will cancel out. So you ultimately get x plus 1 over negative 5x plus 1. Okay, and so at this point, we know the denominator can't equal 0. So negative 5x plus 1 cannot equal 0. So negative 5x cannot equal negative 1. So x cannot equal negative 1/5. Additionally, if you have a denominator of 2x anywhere in the function, then if x was equal to, x cannot be equal to 0, because then you'd be dividing by 0 at some point. So because of that, x cannot equal 0, x cannot equal negative 1/5. So our domain is, I'm sorry, divide each side, that's just going to be positive 1/5. So x cannot equal 0, x cannot equal 1/5. So that means the domain is from negative infinity to 0, 0 to 1/5, 1/5 to infinity, based on our domain restrictions. Additionally, another method is putting the composition into the calculator. If we can turn this on. So if we can use the equation x plus 1 divided by two x, that's a self-contained unit, divided by so this is the entire term, x plus 1 over 2x, x plus 1 divided by 2x. I should do a second parentheses here. Divided by x plus 1 divided by 2x. All right. And then that's all minus 3. We can look at the table here. All right, so we have an error at 0. Now let's look at when x is equal to 1/5. So let's look at the table start at 0.2. And we know that because we can look at the table start as at 1/5, because that's a domain restriction given in the multiple choice answers. So that's a good hint on that's something to check. And at 1/5 we also have an error. So that's another way, plugging it into the calculator and then looking at the domain restrictions. Anytime there's an error, there's going to be a domain restriction. All right. So that was number 2. Let's go to number 3. If f of x is equal to negative 4x plus 2, and g of x is equal to the square root of x minus 8, when does f of g of x equal negative 6? So we need to find f of g of x first. So f of g of x is going to be equal to negative 4 times the square root of x minus 8 plus 2. And so this value has to equal negative 6. So negative 6 is equal to negative 4 times the square root of x minus 8 plus 2. So first step is to subtract 2. Negative 8 is equal to negative 4 times the square root of x minus 8. We're going to have to divide by negative 4. So negative 8 divided by negative 4, that's going to become positive 2. So 2 is equal to the square root of x minus 8. So we're going to have to square both sides. 2 squared is 4. 4 is equal to x minus 8. Add 8 to each side. And x is equal to 12. C, x is equal to 12. So that's problem number 3. Moving on, going to problem number 4. What is the inverse of y is equal to 2 to the 3x power plus 4? So we need to find the inverse. Y is equal to 2 to the 3x plus 4. X is equal to 2 to the 3y plus 4. And we need to isolate y. So let's start getting the y term by itself. Subtract 4. First, focus on addition. X minus 4 equals 2 to the 3y. And we need to get our variable out of the exponent. So we're going to have to do a logarithmic convert this exponential function to a logarithm. Log base 2, swoosh across the equal sign, of x minus 4 is equal to 3y. So to isolate y, we have to divide each side by 3. So y is equal to the log base 2 of x minus 4 all over 3. So the answer to problem 4 is choice C. What is the inverse of h of x is equal to the cube root of x minus 3? Well, h to the negative 1 of x is equal to x plus 3 cubed. So that's the answer. Let's see how we get it. X is equal to the cube root of y minus 3. Add 3. X plus 3 is equal to the cube root of y. Okay, cube each side. X plus 3 cubed is equal to y. We have isolated y. This is a function. So the answer is, and so this is equal to the inverse of h of x. That's equal to 5. H to the inverse of h of x is equal to x plus 3 cubed. Moving on to problem 6. What is the inverse of the natural log of x plus 3 minus 1? So switch the x's and the y's. x is equal to the natural log of x plus 3 minus 1. We need to understand that the base of the natural logarithm is e, so x is equal to the log base e of x plus 3 minus 1. We're going to have to do swoosh our logarithm because we need a, oh, sorry, and this is a y. This is supposed to be a y here because we're trying to isolate y. So we isolate y, so we need to get a y out of our logarithm input variable. So we're going to have to swoosh the logarithm. The base e raised to the, but before we do this, we have to add 1. So sorry. So x plus 1 e raised to the 1 plus x, or x plus 1 power, is going to be equal to y plus 3. So to isolate y, we have to subtract 3 from each side. Y should be equal to e to the x plus 1 power minus 3. So e to the x plus 1 power minus 3, that is the inverse of f of x. So the answer to 6 is D. What is the domain of the inverse of f of x if f of x is equal to x plus 3 over x minus 2? So first we need to find the inverse. Switch the x and y's. X is equal to y plus 3 over y minus 2. Now we have to multiply each side by the denominator. So multiply the left side by y minus 2. Multiply the right side by y minus 2. Multiply it out. On this side, it's going to cancel. And here, x times y minus 2 times x becomes xy minus 2x is equal to y plus 3. Now, our next step is to isolate all of the terms with the y and get them on one side of the equation, and then get all other terms that don't include the y to the other side of the equation. So we will have xy. We're going to have to add 2x to each side and then subtract y to each side in order to get all the y's on one side of the equation, all the x's on the other side of the equation. So you have xy minus y is equal to 2x plus 3. Now the next step is we need to factor out a y. So when we factor out the y, we can take out a y, and we will have left over xy divided by y is just x, and negative y divided by y is just minus 1. So y times with the x minus 1 factor out is equal to 2x plus 3. Divide each side by x minus 1. And you have y is equal to 2x plus 3 over x minus 1. All right, so we found the inverse. So now we need to make sure we're not dividing by 0. So if x minus 1 cannot equal 0, because we can't divide by 0, add 1 to each side. X cannot equal 1. And if x cannot equal 1, our domain is from negative infinity to 1, union 1 to infinity. So that's answer choice A. Moving on to problem 8. F of x is equal to 3x squared minus 2, and g of x is equal to the square root of x minus 9. What is the composition of f of g of x? Okay, so we need to find the composition. And g of x is going to go inside f of x. So we're going to have 3 times the parentheses of x minus the square root of x minus 9 squared minus 2. So order of operations, we're going to have to square what's in the parentheses. So we become 3 times x minus 9 minus 2. Distribute the 3. 3x minus 27 minus 2. And then we can simplify the 27, negative 27 minus 2 into 3x minus 29. And so that means that f of g of x is going to be equal to 3x minus 29, which is going to be answer choice D. Sorry for the bad handwriting, guys. Moving on to problem number 9. If f of x is equal to negative 2x plus 12, and g of x is equal to the square root of x plus 2, what is the domain of g of f of x? F of x is equal to negative 2x plus 12. G of x is equal to the square root of x plus 2. We need to find the domain of g of f of x. So we need to plug f of x into g of x. So we're plugging f of x into g of x. So we have the square root of negative 2x plus 12 plus 2. So combining this, we have the square root of negative 2x plus 14, and the domain of this function, remember this is all equal to g of f of x. The domain of this function is going to be any value, so you're not taking the square root of a negative number. So you cannot take the square root of a negative number, so the term inside the square root function must be greater than or equal to 0. Otherwise, the term under the square root number is going to be negative, and you can't take the square root of a negative number. So negative 2x plus 14 must be greater than or equal to 0. Subtract by 14, and we have negative 2x has to be greater than or equal to negative 14. Divide each side by negative 2, and x is going to be less than or equal to 7. Note that when you divide by a negative number, you flip the sign. So you divide by negative number, flip the sign. Flip the inequality. So flip the inequality. So dx is less than or equal to 7. All right, so that's problem 9. Let's go to problem 10. What is the inverse of f of x is equal to x squared minus 10x plus 4 if x is greater than or equal to 5? So we just find the inverse. X is equal to y squared minus 10y plus 4. And actually what I'm going to do is I'm going to leave some space here. In order to isolate both of these y's, we're going to have to complete the square. So you're going to add a complete the square term on the left and the right. So in order to complete the square, we have a negative 10. So we have to complete the square, we have to take negative 10 divided by 2. That's equal to negative 5. And then negative 5 squared is equal to 25. So that's equal to 25 and 25 in each box. So you have x plus 25 is equal to y squared minus 10y plus 25 plus 4. All right, now this will factor into, what was the first term from completing the squared? X minus, or y minus 5 squared. So, and we can subtract 25 from each side. So y is equal to x is equal to y minus 5 squared plus 4 minus 25. So that's going to be plus 21. Now we need to isolate y. X minus 21 equals y minus 5 squared. Take the square root of each side. The square root of x minus 21 is equal to y minus 5. Y is equal to the square root of x minus 21 plus 5. So we've isolated y, so the inverse of f of x is equal to the square root of x minus 21 plus 5. Problem 11. Donovan is arguing a friend about the relationship between the inverse and composite functions. For the functions f of x is equal to 5x minus 8 and g of x equals 1/5 x plus 8/5, Donovan states that since he took the composite of f of x, f of g of x, the result was simply x, and that the functions must be inverses. Which statement is true about the situation? Donovan is correct. If you take the composition of two functions and the output is x, the functions are inverses. All right? So, I mean, let's prove it. Let's take f of g of x. Let's say 5 times 1/5 x plus 8/5 minus 8. If we take the composition, that's going to be equal to x plus 8 minus 8. The 8's cancel out, so that is equal to x. That does mean that f of x and g of x are inverses of each other. All right, problem 12. What is the inverse of f of x is equal to 1/3 times 2 to the x minus 1 power plus 5? Well, the inverse is going to be x, so we need to switch x and y's. X is equal to 1/3 times 2 to the y minus 1 plus 5. We will have to subtract 5. X minus 5 is equal to 1/3 times 2 to the y minus 1. Okay, our next step is to multiply each side by 3. We'll multiply each side by 3. The 1/3 cancels out. We'll multiply this side by 3. 3 times x is 3x. 3 times negative 5 is negative 15. 3x minus 15 is equal to 2 to the y minus 1. Now we need to get the y out of the exponent of that, make y not an exponent, so we need to get out of the exponential term. So we need to take a logarithm. The log base 2 of 3x minus 15 is going to equal y minus 1. Add 1 to each side, and y is equal to the log base 2 of 3x minus 15 plus 1. So the inverse, that's a legitimate function. So the inverse of f of x is equal to the log base 2 of 3x minus 15 plus 1, making the answer choice to 12B. That is your inverses in common composites video. Have an excellent day.